Thank you very much for joining me here today as part of our webinar series around the topic of observability. My name is Paul Winchester. I'm a consultant here at Somerford Associates, and I'm going to be taking you through some of the important aspects of observability to consider when planning and considering this very broad topic. So hopefully there'll be some good things to pick up from this, and we'll also be following this up with a deep dive webinar in, I think, 4 weeks' time. So please look out for invites for that as well. Okay, first we need to get the legal bits out of the way. We'll be talking about the Splunk Observability Suite a little bit. Really, I'm talking primarily around observability as a concept. But where we do talk about the suite of tools, there may be some forward-looking statements of decisions that perhaps haven't been fully made yet. There'll be a couple of things I refer to as being in the pipeline. These things may not come to pass, so please make your decisions based on what is available today. Okay, with that out of the way, let's have a quick overview, a quick look at what we're going to be covering in this session. So we're going to have a look at the general concepts behind observability, what it is, why it's important. And off the back of that, we're going to discuss the types of data we need and what we need that data for. How are we going to collect it? We've got different types of data to consider. Each has their own method of collection. So how are we going to do that? And then a bit of a look at what actual steps we need to put in place. What are the kind of tools and mechanisms we need to put in place to gradually build up our observability capability and move towards that kind of high degree of observability and efficiency in this sort of space where it is impactful. And then I'm going to briefly show what tool set is available within Splunk Observability to show how a comprehensive and cohesive tool set that works together effectively can really help address the challenges that observability presents. Saying observability and certainly typing it is one of those challenges. Okay, so we're going to start with the 5 W's. Firstly, what do we actually mean by observability? Well, at its simplest, I kind of think of observability as just the ability to see what a system is doing. More formally, you might get a definition like observability is the ability to measure the internal state of a system only by its outputs. We deal with a lot of black boxes where inputs go in, something happens, output comes out, and it's based on those inputs and outputs that we are trying to observe how the system is behaving as a whole. So why is this important? And why is it something that's becoming more talked about at the moment? Well, an observable system or observable systems enable you to understand complex system behaviors, so you can more easily navigate from the effects to the causes and move from issues to resolutions. That complexity has been driven by the direction that development of applications and platforms is going. So, okay, who needs it then? Well, as I was saying, their business is moving away from traditional systems, monoliths, simple structured systems, to more flexible, modular, and dynamic systems, which greatly increases the complexity of those systems, and therefore the monitoring requirements for ensuring optimal performance become increasingly complex. So who needs it? Well, anyone who is pushing their business development in that direction. Okay, moving on to whereabouts is it required? Well, it might be in your web or mobile front end, in your application at the back end, your underlying infrastructure, whether that's in the cloud or on-prem, or all of the above. Some or all of these areas are necessary to provide that holistic view of your systems, and that's really the key driver for observability, that overview, that single pane of glass, whatever phrase is most relevant to you, but that is the big picture, trying to collect all of it together to give that big picture. When do we need it? Well, the answer to this is nearly always right now, but really what I'm talking about here is at what stage in that development cycle, that journey that you're going on, whatever you call it, that digital transformation journey, whatever particular phrase is used within your business, well, ideally as early as possible. And the reason for that is that you really want to bake in the instrumentation and the processes and things we're going to be talking about in at the start to make it easier to then make that part of just how you operate. However, it doesn't have to be at the start. It can be introduced at any stage. It's just ideally you get in there really early to really make this part of, making the instrumentation part of the process. Okay, I said we'll move on to how. So here we are. How do we make systems observable? Simple answer is with data. Okay, without data, we're going to be blind. You might hear this phrase, the 3 pillars of observability. I put it in here because it's catchy and easy to remember. It's a simplification, there's more to it than this, but it does help as a starting point. Metrics, traces, and logs. Metrics indicate that there is a problem. Okay, something deviates from a threshold, from an ideal value, from some sort of service level agreement or service level target. Metrics tell you that something's not right. Traces and the spans that make up those traces show where in your system that problem is. What parts of your services, which of your services are impacted, and what's upstream, what's downstream, and you can start to home in on where in your system something's gone wrong. And the logs provide the detail. The logs should be there to tell you what it is that happened when that thing went wrong. So we're going to have a look at each of these in a bit more detail. Metrics. I think Google specified these. Apologies if that's wrong, but I think it's Google who came up with 4 golden signals. But it makes a lot of sense. These are key types of metric data that we need, and we're going to have a look at this and talk about how we collect them. So a metric is a value that expresses some data about a system. These metrics are usually represented as counts or measures and are often aggregated or calculated over a period of time. A metric can tell you how much memory is being used by a process out of a total, or the number of requests per second being handled by a service. A couple of examples, there are thousands. We need to collect metrics to help us identify when there is a problem, and the following have been identified by Google, I think it is, as the most critical to capture. So first up, latency. Very simple. How long is a request taking? How long does that particular operation take? Then traffic. So how much demand is there? How much load? How many requests are coming through your system? Errors. Always an obvious one, really, but also always key. What is the rate that those requests, that traffic fails, or complete, but perhaps complete partially? Errors aren't always bad as well. Sometimes you get errors that are not important, or they're only important in the context of something else happening. So we need to collect the information about errors. And then saturation. How are your underlying resources holding up to the load? Okay, you can have a high level of traffic, but if your system is set up to manage that, then the saturation won't be too high and will be within whatever constraints that you've set. So this data is produced by cloud systems, by on-premise systems, and can be collected by using agents to send to a centralized platform for monitoring. That's a model we're all pretty familiar with. From there, we can apply whatever logic meets our operational needs to produce visualizations and alerts based on your team's objectives and targets. Okay, so broadly speaking, that's what we would talk about in terms of monitoring. One question that does come up, which I'll just take a sidetrack to now, is what's the difference in monitoring and observability? Generally speaking, when you're doing monitoring, you have metrics, usually target figures, thresholds perhaps, and you know what the figures are and what's good and what's bad. Observability builds on that and takes it a step further and says, okay, we know what's good and bad for each given metric, but what's good and bad as the big picture? And how do we deal with the fact that we don't know what that is until we start? So observability is really about that complete picture, whereas monitoring is more targeted. Okay, moving on. Quick sidetrack there. Traces, request tracing. So a trace is a collection of spans, each one of which represents the execution of some action within a system. A trace, therefore, follows a session through a system, showing the steps it took, services it interacted with, and how long each step took, giving vital insights into the relationship between services. Traces are a critical part of observability, as they provide context for other telemetry. For example, traces can help define which metrics would be most valuable in a given situation, or which logs are relevant to a particular issue. For troubleshooting, it provides valuable information about exactly where the problem occurred within an application's workflow and where teams should focus their attention. There are a wide range of out-of-the-box solutions for capturing traces, but often custom instrumentation or custom metrics will be needed to create, will need to be created to catch key information specific to your application's use cases. Your observability toolset needs to be able to manage both scenarios. So we've looked at what traces are. What do you tell you about the system in terms of how those services are interacting? I should stress there how they're actually interacting, not perhaps how you design them to. And yeah, we need out-of-the-box instrumentation to get us quick time to value, but also the capacity for custom instrumentation to really target what your particular application and your systems need, what your teams need to know about them. Okay, on to logs. Logs are there to answer the question, what happened? Okay, the metrics told you you've got a problem. Your traces and spans have identified where in the system it is, and you drill down to the logs. And the logs tell you what happened, or they should. They're needed to give you details of what's happening with descriptions of errors and other vital debugging information. For off-the-shelf solutions, SaaS platforms, and other standardized tools, the logs, if they're available, will be structured and should be relatively easy to onboard. For custom applications, a structured and consistent logging strategy is key to providing the information required for fast and effective root cause analysis. If you're building your own applications, whether that's an e-commerce platform or a tool for use internally, if your developers are logging the data or logging information as it goes, it's crucial to have that as part of your strategy. Those logs need to be clearly date stamped with genuinely meaningful error messages that can be interpreted for the purposes of troubleshooting and root cause analysis. So it's particularly important for debugging and error handling, since it provides key forensic information for developers to identify faulty components or problematic component interactions. So we're talking about complex systems where services, microservices, or whatever they might be, are interacting with each other, and we need to be able to identify as much detail as possible about what's going on. It's not always about errors as well. It can just be about reporting on correct and normal activity too. Also very, very important. Right, let's get to the crux of this. So how do we build up towards full observability? And by that I mean, this is not a big bang, one solution scenario. This is more of a process. Okay, this is something we're going to build up to over time as your applications are developed, as your business needs change, your observability solution needs to work with that. So how do we do that? Okay, we're very focused on technology, quite rightly. That's what we're here to provide in terms of our services. And technology is one of the key components. But we need to have good processes and good people to make that technology work for us. So let's think about those three areas. Technology first. Let's get that out of the way. We've looked at the types of data we need to collect, our metrics, traces, and logs. We also need the right tools to collect that data, to process it, and provide your end users and teams with the visualizations and alerts they need, and indeed anything else that they need. We tend to focus on visualizations, alerts, but there's more to it. There's the ability to feel that your you've got that oversight, that overview, to feel that you've got all the information you need to be able to make the decisions you need when running these sorts of systems. There might also be more specific requirements as well, such as tracking deployments to understand the impact of code changes, things like canary pushes. Getting the technology right underpins everything we're trying to achieve with observability. Okay, so that's great. We need good technology. That's a given. We all understand that. We also need good processes. So to help with the goals of observability, and to ensure that your teams have the structures that they need to be able to work together effectively, we need good processes. This starts with how the data is collected and analyzed, how the alerts are managed, and how analysts, operators, and support staff respond to incidents and then review them afterwards. We can use service level objectives to define goals and set expectations that can be revised and refined over time. It's an ongoing kind of evolutionary feedback loop that can continually improve and refine the elements that make up your operational approach. Okay, so there's got to be an alerting strategy that determines how you're going to build your alerts. An operational model to say, once that alert is triggered, that information is shared, how do you run through the steps in order to address the nature of that alert? Once there's been an incident, because we know this is always going to happen, things are going to go wrong, we need to be able to look at it forensically and identify, firstly, what went wrong and why, and also, did the process that we built, that operational model, address that incident effectively? And those service level objectives can be monitored and over time, and then say refined and stepped up and expanded as needed to meet your operational needs. So we need good processes, and we also need the right people doing the right jobs with the right tools to do that. So the types of systems businesses are running now, high-end user expectations and the demands of regular development and deployment cycles, new roles such as the site reliability engineer is becoming more important. They're usually responsible for such things as availability, latency, ruthless efficiency, and nice red uniforms. Sorry, scratch that. Monitoring, change management, capacity. Yeah, okay, you get that. Lots of things that SREs can do. New technologies also require appropriate training to ensure the maximum effectiveness of value, so you can get the most out of your tools. You can put the right tools in, you can set everything up. If people don't know how to use it and how to get the most from it, it's not going to work. Okay, so 3 components there: technology, processes, and people. Okay, we're focusing, as I say, on the technology side of things. So what can Splunk Observability Cloud offer us? Well, it's a solution that meets all of the needs we've described, and can support, and we at Somerford can support you in your push towards a complete observability solution. Observability Cloud is a suite of tools covering all aspects of observability. Let's start at the front end, RUM and synthetics over here on the right. So with real user monitoring, RUM, the code that performs your website or part of your mobile app will report on the sorts of metrics that we've looked at, we've discussed, and also provide traces to show what's happening step by step. This is really important. Your backend may look like everything's working properly, but if your users are having a poor user experience, then you're going to be potentially losing business. So real user monitoring is a key part of understanding what's actually happening on the browser's device, on the user's device. Synthetics is related to this, but rather than real users, we have synthesized users. Okay, we can synthesize load on a system to check that you've got the capacity and bandwidth to be able to process large volumes. We can also use that to test how we would expect behavior from different global locations. Okay, different geographical regions may behave differently according to their local conditions. We can also use it to do things like show how a page will actually load for a given user. Okay, a great feature in Splunk Synthetics is the ability to generate a video of what the screen actually looks like moment by moment as it's loading. Really important for things like if you are presented with a blank screen for 5 seconds and then suddenly everything loads at once, your users may have gone already. If something loads quickly, but then you can't interact with it, that's really frustrating. So all of these sorts of things are captured by Splunk Synthetics. So front end, we've got real user monitoring and synthetic. Then we move into the application layer and APM, application performance monitoring. Now this sector's been around for probably 15 plus years since it was sort of defined as its own area. This is really where the spans and traces come into their own. Splunk APM takes all that information and builds out a service tree. You can just about make out in the picture here, and do come back for our deep dive for a proper look at this, but really it builds out this service tree based on the actual interactions that are going on between these services. So it's not something you have to predefine and say, this is my service tree, this is what it should look like, because it may not operate like that. You may have designed it to work like that, but it may not be working that way. So this will show you what's actually going on and hotspots within the system that indicate that you may be having problems in that area and things like that. So like I say, come and have a look at the deep dive for more information on that. So that's our application layer. And then sitting underneath all of that is our infrastructure. Okay, classic infrastructure monitoring, something we've all had to do since day one in IT. Whether that's cloud solutions, the 3 cloud providers are all well catered for by this solution, or on-premise hardware, virtualized hardware, all of those things, Kubernetes, clusters, all these sorts of technologies are well supported on the infrastructure monitoring side. So we've had metrics coming out of infrastructure monitoring, traces and spans coming from being collected for APM and RUM. We also need logs. Okay, Splunk is known for logs, log analytics, log aggregation, and Log Observer sits as a simplified interface, so no SPL or no Splunk Splunk coding to manage, just a simple front end with the ability to do searches within your logs, and that log data from all of those sources is collected in the Log Observer. I'll come back to that in a second. So we've also talked a lot about alerting strategies, alert management. Okay, we all know of the perils of alert storms, where there are too many alerts and they're poorly organized or they're going to the wrong people. Splunk On Call helps with that. The alert creation is managed through the core observability platform. But then when it comes to actually directing that alert to the right person, Splunk On Call is your key component of that. Okay, it can manage teams, have people who are on and off at different times of the day, have escalation policies and all those things that you need in order to make sure that your alerts are getting to the right people at the right time. And observability, the observability suite can also tell you more. It can tell you about your users, your digital experience monitoring. Okay, so we talked about how RUM and synthetics can give you that end user experience. So digital experience monitoring can be brought into this as well. Web optimization, again, through the synthetics tool. And incident management, bringing all of this together. Splunk On Call, directing alerts to the right people, and your alert strategy being built around that, driven from all of these tools, the infrastructure monitoring, the APM, RUM, all of those can be used, and Log Observer can be used to drive your alerting and so your incident management overall. Okay, so what are the benefits? Well, firstly, and this is a key differentiator, you've got all of the data, okay? There's no sampling. All the data is collected from all of these tools. You have a full picture at any given moment in time. If you're looking back at an incident, all of the data is there to look at. If you're in the middle of an incident and you're trying to fathom out what's going on, all of the data is there. All of those sources, your infrastructure, your applications, from your front end, all of it. It's real time and highly scalable. Okay, there's no delay in seeing what's happening, and scalable for whatever your future ambitions might be. Okay, you can start small and build large. Analytics and machine learning. An example is that root cause indicator in the application performance monitoring tool. There are algorithms in the system that try to identify likely root cause. Okay, just as a guide, as a starting point to help you home in. And again, come to the deep dive webinar and we'll show that in action. It's built into the product. It's not an extra you have to pay for. Okay, it is part of the core product. And it's also, in terms of the collection process, open source. And this is really key. Splunk is part of the Open Telemetry project, and this is looking to standardize collecting these metrics, logs, and traces in a way that can be used in any application. And we've got there are some big companies involved in this as well, the likes of Google, etc., to standardize this so that you don't have to stick with one tool. Okay, you're not tied in by a bespoke tooling solution. You're using a genuinely open source tool. So you've got Splunk. So Splunk Observability uses the Open Telemetry collector, and it's backed by Splunk and other industry players. So if you need to switch to another vendor, you don't have to rework all your tooling. Okay, just make that change as needed, and your tooling will still work. So what are the benefits of all this? Well, we can improve customer experience. We can improve release quality and speed to release, okay, because you've got that ability to see what's happening in your system in real time. So when changes are made, you can immediately see if there's a problem. That improves developer efficiency, allowing you to get more from your developers. And it also makes your business more flexible, more adaptable to what is becoming increasingly, crazy world. Okay, so a few conclusions, a few parting thoughts here, and thank you again for your time this morning. Embrace the mess. Now, I don't know if there are any fans of the series Only Murders in the Building. This quote comes from there, but I'm sure it comes from other places as well. Risk management is a key part of taking your business and your development and your systems in this general direction. And observability gives you the tools to confidently manage that risk. Okay, we tend to have a tendency to be risk averse, particularly around business critical systems, understandable. But business drivers are pushing towards more flexibility and agility, in turn leading to greater complexity, and things will go wrong. Okay? If anyone's been around IT more than half an hour, you know that things will inevitably go wrong, however stringent your processes and systems are. It's probably going to happen quite a lot. Observability provides a set of tools and practices that will allow problems to be resolved faster with lower impact on customers. Building up your capabilities that match those increasing demands will help you and your teams embrace the future. Collect the right data, metrics, traces, and logs. And importantly, use all of that data. Okay? No sampling, you've got all of the data all of the time. With metrics, traces, and logs, no sampling, you can answer any questions you have on what your systems are doing or was doing and why. To build to a high level of observability, we looked at 3 areas: technology. Hopefully the solutions presented to you are look to address those needs. The processes, how do we actually go about using that technology effectively within your business and within your teams, and the people themselves, what their roles are they fully trained to really get the most out of these tools. Ideally, build this in early, and set up those effective processes, and then keep refining them and refining them and refining them. Build up your capabilities with the right tools for the right people, and you will achieve a high degree of observability. What can Somerford do to help? Well, we run workshops. Okay, I run one on observability. It's about 3 hours long, and we go into all aspects of the observability suite. But I might have to make it longer because there's so much to get through. We have our webinar series. As I mentioned, I think it's 4 weeks' time today. We'll be moving on to the deep dive, getting really into the nuts and bolts of how the different parts of the Splunk Observability Cloud and what they offer. And I've just realized there's one really crucial thing I've not mentioned about that, so hopefully you're still with me. These tools all work together and are interlinked. Okay. The reason why the Observability Cloud provides such an effective tool is that you can be in your real user monitoring tool, and you'll see there's a link to APM. That will take you to the specific traces that related to that specific session for that particular user at that moment in time. So you see there's a problem that the user is experiencing, you can drill down to the APM tool to have a look at what was happening in the application layer at that moment in time. From the application performance monitoring tool, you can also link to the infrastructure monitoring and the logs. So you're looking at a particular trace. You want to know what the infrastructure was, how it was behaving at that moment in time. So you click and link through to the infrastructure. You want to see what logs are being generated for that particular object at that particular time, and you can drill down to that as well. All of that is integrated in the same interface, and that's key to that holistic approach. Just made that point now because I should have made it about 10 minutes ago. So hopefully you stuck with me to this point. So yeah, webinars are following on from this. We have blog posts, and we're also going to be doing a video series to explain little nuggets of how Observability Suite and how observability can be, how Observability Suite works, and how we can move things forward in terms of providing observability methods within your organization. We're an elite Splunk partner. We've got experience in a wide range of industries, and our technical team now is growing larger and larger all the time. So we've got a wealth of experience across the team. So yeah, do give us a call if you want to discuss anything. Please contact me, feel free if you've got any questions. And with that, thank you again for your time. I look forward to our next meeting, and enjoy the rest of your day.